Good morning, tenors. The previous day we studied Gay-Lussac's law of combining volume. What does it state? It states that whenever gases react, they do so in simple volumes, which bears a simple whole number ratio to one another and to the product, provided it is measured under similar conditions of temperature and pressure. Now today we are going to begin with Avogadro's law. He was a famous Italian scientist, and according to him, what is an atom? An atom is the smallest particle of an element which can take part in a chemical reactions and may or may not exist independently. You have already studied this in class 9 also. What is a molecule? A molecule is the smallest particle of an element or a compound that can exist independently. Now, Avogadro explained gas laws like Boyle's law and Charles' law by assuming that equal volumes of all gases or the same temperature and pressure contain the same number of molecules. When this was put forward, it was purely hypothetical. Now, what does Avogadro's law state? It states that equal volumes of all gases under similar conditions of temperature and pressure contain the same number of molecules. What does that mean? It means that under similar conditions of temperature and pressure, equal volumes, let's say I take 1 liter of hydrogen gas in one cylinder, in another cylinder 1 liter of nitrogen gas, in the third cylinder I fill it with 1 liter of oxygen gas. All three, when measured under similar conditions of temperature and pressure, contain the same number of molecules. If there are n molecules in nitrogen gas, then it will be n molecules in oxygen. It will be n molecules in the third container that you have taken. Now, by applying Avogadro's law, let's take a look at this example. Hydrogen gas reacts with oxygen to give you water. Now, 2 volumes of hydrogen gas reacts with 1 volume of oxygen gas to give you 2 volumes of H2O. Now, this is Gay-Lussac's law of combining volumes. By volume, it is 2:1:2. Now, when we come to Avogadro's law, let's say hydrogen gas, how many molecules? 2 molecules. Oxygen gas, 1 molecule. So 2 molecules of hydrogen gas reacts with 1 molecule of oxygen to give you 2 molecules of H2O. Now, we come across the term atomicity. You've been studying since class 7. Atomicity is the number of atoms in a molecule of an element or a compound. So, according to atomicity, it is the number of atoms possessed in a molecule of a substance. So, there are monoatomic molecule, diatomic molecule, triatomic molecule, and polyatomic molecule. So, monoatomic molecule is composed of only one atom. For example, the noble gases helium, neon, argon, krypton, etc. So, the atomicity equals to 1. Diatomic molecules consist of or is composed of 2 atoms in its molecule, like hydrogen gas, oxygen gas, chlorine, etc. So, the atomicity equals to 2. Triatomic molecule is composed of 3 similar atoms. For example, ozone, it is O3, and that is atomicity equals to 3. Then comes polyatomic. Molecules are composed of more than 3 atoms. For example, P4, that is phosphorus, tetraatomic, atomicity equals to 4. Then we have S8, that is sulfur. It contains 8 atoms in its molecule, hence the atomicity equals to 8. Now let us take a look at a numerical based on what we have studied. Look at this question. Under the same conditions of temperature and pressure, you collect 3 liters of carbon dioxide, 4 liters of chlorine, and 6 liters of hydrogen, 5 liters of nitrogen, and 2 liters of sulfur dioxide. In which gas samples will be there? You are supposed to calculate, number one, the greatest number of molecules. So which law I'm going to apply? Avogadro's law. Number two, the least number of molecules, and justify your answer. The solution is given. Equal volumes of all gases under similar conditions of temperature and pressure contain the same number of molecules. So under the same conditions of temperature and pressure, if the volumes of the gas is decreased, the number of molecules will also decrease. Hence, what have you learned? It is the equal volumes of all gases under similar conditions of temperature and pressure contain the same number of molecules. Now, first one, 6 liters of hydrogen contain the greatest number of molecules. Very true. And the second one is least. Obviously, the volume which is the smallest, that is 2 liters of sulfur dioxide, contains the least number of molecules. Now there is another problem is given here, which I would like to show to you. If 300 centimeter cube of hydrogen contains n molecules, how many molecules of oxygen will be present in 150 centimeter cube of oxygen under similar conditions of temperature and pressure? Look at the solution. 300 centimeter cube of hydrogen contains how many molecules? N molecules. It is given in the question. Therefore, 300 centimeter cube of oxygen also contains N molecules. Why? Because of which law? It is Avogadro's law. Therefore, 150, that means half the volume of oxygen, will contain N by 2 molecules. That means half the number of molecules. So it is fairly simple. You simply have to have a clear concept of Avogadro's law and practice the numericals. That brings the end of the lesson today. And please do the assignment neatly and correctly. Thank you.